As iron is relatively unreactive, its oxide can be reduced to the metal by heating it with carbon. A similar process is carried out industrially in a blast furnace. The Royal Society of Chemistry have a nice little experiment carrying this out on a microscale. It suggests using a strike anywhere match. The problem is that these are no longer available in the UK as a result of EU restrictions on the use of phosphorus. However, it turns out that not only do you not need strike anywhere matches, you don't need a match at all. Take a wooden splint and put it into some water for a few minutes to get it quite wet. Now make a roughly 1:1 mixture of sodium carbonate and iron oxide. Make sure it's mixed thoroughly. I'm grinding them together in a pestle and mortar here. Take the splint out of the water and dip it into the powder to coat the tip thoroughly. The point of getting it wet is simply to make sure that the powder sticks to the wood. Now put the splint into a Bunsen burner flame and burn it strongly. You can't overheat it, but you will find that the non-coated part of the splint burns as well and the end can fall off. But this isn't a problem. The iron oxide is being reduced to metallic iron by the carbon from the splint. The sodium carbonate melts easily and its role is simply to bring the iron and carbon into close contact. Let it cool for a few seconds, then grind the burnt tip of the splint. I'm using a pestle and mortar here, but you could probably just crush it with a spatula. Now to test it. It is easy to test for metallic iron as it is the only common metal that is significantly magnetic. Wrap cling film round the magnet to stop any iron particles sticking to it and dip it into your powdered mixture. As you can see, there are some particles of iron that are sticking to the magnet. Another way of showing this is to put the powdered mixture into water. Now you can apply the magnet to the outside of the glass. You can clearly see again that the magnetic particles of iron are attracted to the magnet, thus showing that the iron oxide has been reduced to metallic iron.